Let's talk about radians. What is a radian? Well, a radian is just a unit we can use to measure angles, just like degrees, right? But just like anything else, like if you're measuring distance, you have miles and kilometers, inches versus centimeters. It's kind of a similar idea where we have two different units to measure the same thing, and we can actually convert between the two if we want to. Now, where does radians come from? Well, radians actually is pretty intuitive once you see what it is. We have this equation, it's S over R is equal to theta, where theta is your angle in radians. So this is where this comes from. It's equal to S, which is an arc length, divided by R, which is a radius. Now, let me show you what I mean, and this might make a little bit more sense. So all that's saying is that if you have an angle like this is your angle theta, right? And this is the length of R, and this is the length of R, right? That's your radius. And this here is your arc length, right? That's the curve. If you're going to continue this, you would get a full circle, but we just have it here. So this length here is your S. So if you have any angle like this, you can measure this length here, the radius, divide them, and that gives you the angle in radians. So the angle in radians represents a ratio between the side lengths of the arc length and the radius. Right? So it's not just something we made up. Like if you think of degrees, for example, degrees are a unit that we kind of made up, and we made a full circle 360 because that was a number you could break up into several different ways, right? It was just a very nice number to have. And there are other units as well. But for radians, it's simply the ratio between these two sides, which makes it pretty nice and pretty intuitive. And so because R and S would have the same units, right, they're both distances, when you divide them, when you do S divided by R to get your angle, that's going to be unitless, right? So radians, even though we call that angle radians, radians actually doesn't have a unit. So how do we express a radian, right? Do we just write it as a number, like as a decimal? Like what do we do? Well, what we can say is that one full rotation, in the past we would call that 360 degrees, right? But now what we're going to say is it's equal to 2 pi radians. So you might see some people put RAD next to that to show that we're talking about radians, but it's unitless, so you don't really have to write that. You can just say 2 pi. Okay? So 2 pi radians represents, so 2 pi represents one full rotation around a circle, the same way that 360 degrees would. And we can actually make a connection here with our circumference equation, right? If you recall, the circumference of a circle is equal to 2 pi r. Well, if the radius of the circle is 1, then that would mean that the circumference is equal to 2 pi, right? 2 pi times 1, so just 2 pi. And if we're talking about a circumference, the circumference is really an arc length, right? It's the length of that curve, except it goes all the way around, right? So if you're thinking of a circle like that, pretend it's a nice circle, and you have a radius here of 1, that's your radius, and you go all the way around the circle, so your angle is 360 degrees or 2 pi radians, then the arc length is the entire circumference. So we can say that the arc length is equal to theta times the radius, right? That's just rearranging the formula I showed earlier that says that the angle is equal to the arc length divided by the radius. Just rearrange it to this. And the angle here is just equal to 2 pi, so 2 pi r. This is your circumference equation, right? So they're both related to each other exactly like that. Now, with that being said, that's just a cool bit of information there. If we want to convert between the two units, right, degrees and radians, we can say, well, 360 degrees we know is 2 pi radians. So half of that, right, 180 degrees is pi radians. 90 degrees is pi over 2. And you can kind of figure out what other angles would be equal to, right, just based on those. So if you're going to label where all these things are, this was 0 or 360 degrees here, because either you start here or you go all the way around, right? But now you could call it 0 or 2 pi. Right, so when you start, you're at 0 radians. When you go all the way around, you're at 2 pi radians. When you're at the top here, we used to call it 90 degrees, but you can now call it pi over 2 if you want. Over here, we called it 180 degrees. Now it's pi. So this is pi if you just go halfway around like that. If you go to the bottom, this was 270 degrees, but you can also call it 3 pi over 2, which is another way of saying 1.5 pi's, right? And then you go all the way and you get back to 2 pi. Okay, so that's what all those angles are. Now, if you have a specific angle and you want to convert it between those units, this is what you have to do. So let's say, for example, you have 45 degrees and you want to turn that into radians. Then you would say, okay, 45 degrees multiplied by, we need a conversion factor. Well, we said that 180 degrees up here, we said that 180 degrees is equal to pi. So we can use that as a conversion factor. We can say that pi over 180 degrees, that will be our conversion factor. And the reason I'm using that is because pi and 180 are the same thing. So when you divide them, this fraction altogether is just equal to 1, which is why we're allowed to multiply it. And the degrees will cancel, right, on the top and bottom, because those are both in degrees. That's the unit. And you're left with radians on top. So when you multiply this together, you're going to simplify this, and it's going to become pi over 4. And again, that's in radians, but you don't have to write that, right? Another example would be if you had 60 degrees and you want to put that into radians. Same thing. You do times pi over 180 degrees, and that's going to equal pi over 3 radians, right? You can do the opposite, right? You can say you have 4 pi over 3 radians, and you want to put that into degrees. How would I do that? Well, for this, you just multiply by the opposite of that conversion factor so that the units cancel. So you would put 180 degrees on top so that you're left with degrees, and you would put your radians on the bottom so that the radians cancel, right? Even though radians don't really have units, but this leaves you with your degree answer, right, on the top. So you simplify this, 4 pi over 3 times 180 divided by pi, you're going to get 240 degrees. So really the pi's cancel, and then 4 over 3 times 180, you get 240. Okay, we can do another one. We can say 6 pi over 7, and I want to put that into degrees. Again, you multiply by 180 degrees over pi, multiply that, and you're going to get 154.29 degrees. So if it doesn't multiply nicely into a number, you might have to round it like this, or have a decimal, something like that, and that's okay, right? Now, typically we'll have pi in our answer for radians. Like if if you're given an angle in radians, it'll be like 6 pi over 7, but it doesn't have to have a pi in it, right? Because pi is just a number. Remember that pi is just 3.14. That keeps going on forever, but it's just a number. And so you could have a radian angle of 1, right? And that would be a little bit less than a third of a way to pi, so a little bit less than 60 degrees, right? So let's say you had that. Let's say you had 1 radian, and I'm actually going to write radian here just to show that's radians. How do you change that to degrees? Well, you multiply it by 180 over pi. And if you do 180 divided by pi, you get 57.296 degrees. You could probably round that, right, to whatever you want. Maybe 57.3, right? Maybe 57.3 degrees or something. But the point is, you don't have to have a pi in your radian measurement. It's just common that you do, okay? So when it comes to converting, you either want to multiply by 180 degrees over pi, or pi over 180 degrees, right? It's the same numbers, just flipped. And you choose based on what you have. If you want to end up with degrees, you have to pick the one that has degrees on top, so you get degrees as an answer. If you're starting with degrees and want to turn into radians, you need degrees on the bottom so that the degrees cancel out, right? And you're left with your radians on top. Okay, so that's the strategy. Now, if we go back to talking about that arc length equation, where we say the angle is equal to the arc length divided by the radius, with this in mind, we can solve some questions, right? Let's say we're told that there's an angle of pi over 3, and the radius is equal to 2. How could I find the arc length? Well, you just have to plug it into here and isolate for s, right? To isolate for s, you just multiply both sides by r. So s is equal to r times theta, which is equal to pi over 3 times 2, which you could just say is 2 pi over 3, right? And if you want to give it as, a decimal, because we're talking about meters or something, and it's not really practical to say, 2 pi over 3 as a measurement for a distance, you could round that off. You could say 2.09 approximately, and just round it off. Or you could leave it like that for an exact answer. And on a test or something, unless you're told otherwise, it's usually good to leave it as an exact answer. Okay, we could do another one. Let's say we're told the arc length, which is s, is equal to 4 meters, and that theta is equal to pi over 2. And they say, what's the radius? Well, same idea. You isolate for r. So r is equal to s over theta, right, which is 4 over pi over 2, which is the same as 8 over pi, right? And that's going to be in meters, right? And you could round that off. You could say that's 2.55 meters if you want a measurement like that. Up to you. Okay, let's do another one. Let's say you're told the arc length is 4 centimeters and the radius is 1.5 centimeters, and you're told find theta, right? What's the angle? Well, you would just isolate for theta. Theta equals s over r, so 4 over 1.5. And that's going to be about 2.667, and that's in radians, right? Now, like we said before, radians don't have to have a pi in them, but sometimes you're able to simplify them so that they do. Sometimes you can't, though, and so you can just leave your answer sort of like that. Or you could write it as a fraction, right? You could say this is the same as 8 over 3 radians, right? Instead of dividing them and rounding, you could actually change 4 over 1.5 to 8 over 3, just so it's a nice fraction. Up to you, though. Okay, now this is why I like radians, because if you told me the angle is 8 over 3, from that, I know the ratio between the arc length and the radius already. I can imagine what this looks like. Even though I don't know 8 over 3, what that looks like as an angle, you can imagine it because you know the ratio of the arc length and the radius, right? So if your, arc length is 8, so a long distance like this, the radius is only 3, so it's like, oh, it's something like that. The radius is a little bit less than half of the arc length, So we're talking about a pretty wide angle. If the radius was a lot bigger than the arc length, then you'd be talking about a small angle like this, where the radius is a lot bigger than the arc length. But we have the opposite going on here. So it's a pretty big angle as opposed to a small angle. So that's why radians is nice. You can kind of envision what's happening.